we're going to be having another problem regarding addition of vectors. So this problem is all about a plane. So number 2, a plane flies from base camp to Lake A at the distance 280 kilometers with the direction of 28 degrees north of east. And after dropping supplies, the plane flies to Lake B, which is 190 kilometers and 30 degrees west of north from Lake A. What is the displacement and direction of the base camp to Lake B? So basically this problem is, it's asking us for the displacement of the entire trip. You know, the trip from base camp to Lake A, and then from Lake A to Lake B. What is the entire displacement of that trip? Now, for a problem like this, let me find my pen. Okay. So number 2, let's write here. My pen. 2. Problem number 2. A plane flies from base camp to Lake A. So let's say this is base camp. And let's draw a Cartesian coordinate plane around it. East, south. At a distance. So from base camp to Lake A, the plane flies at a distance of 280 kilometers with the direction 28 degrees north of east. So let's first establish the direction of it, which is 28 degrees north of east. So when it comes to problems like this, basically regarding a direction, so north of east, that's right here. So let's first take note of the of east part, okay? You know, when it comes to a dialogue like this, 28 degrees north of this. When it comes to a dialogue like this, let's first refer to the off east part. Now, if it says off east, off west, in this case off east, let's point at east first. That's gonna be our first subject. Now it says north of east. Now we're currently at east. Which part of east is the north part or north portion? Is it this one or this one? Of course it's this one. It's north. So this is the portion of north of east. So we went from here up to there. Since the direction is actually going there, that means it's gonna be like this, 28 degrees here. It's gonna be like that. So 280 kilometers with direction of 28 degrees. Yeah, that's gonna be 280 kilometers. Let me just redraw it because that's interrupting in the way now. 28 degrees. Okay, here's a thing to take note as well. The length of the vector would be, the length of the vector should be parallel to what unit is this. Let's say 280 kilometers. Of course, that's going to be longer. The representation of the vector in the graph, it's going to be longer than 10 kilometers, obviously. So yeah. Now, after dropping supplies, the plane flies to Lake B, which is 190 kilometers and 30.0 degrees west of north from Lake A. So now, it's currently here at Lake A. This is Lake A here, so let's draw another Cartesian coordinate plane. (190 kilometers, 30 degrees west of north from Lake A. North, west, east, south. So now we have west of north. Let's write here. West of north. Now of north, let's go from here to north, okay? Because off north, the direction with off is always the first subject. So here. Now which direction here is west? Obviously this one. So it's gonna go there. Now the direction here, that's gonna be the angle. So now, bam. 30 degrees here, 30 degrees. 190 kilometers. 190 kilometers. Now, it's asking us, what is the displacement and direction of the base camp to Lake B? So, our displacement using the tip-to-tail method is this one. That's our displacement plus resultant vector. Yep, that's it. Now, we could actually use two methods, the law of cosines and the analytical method. But the law of cosines, we're gonna cover that in another video. Now we're gonna be using the analytical method first. Now, with the analytical method, okay, we have two separate Cartesian planes here, right? Now we're gonna try to find the opposite and adjacent sides of each of these vectors, because remember, these vectors, as stated before, are basically hypotenuse. No, it's a hypotenuse, and we're gonna try to find the opposite and adjacent sides. The opposite and adjacent sides would now be the anti-parallel and parallel vectors, in which we're gonna add to combine and to form one component vector of the resultant vector, to make it so that we can just use the Pythagorean theorem to find the resultant vector. It's hard to say, but I even had a hard time saying all of that, but we're gonna understand it as we go on. So here, our first one, 28 degrees here, 280 kilometers. Now, the angle we're always going to be referring to starts from the east, okay, east of the x-axis. So 28 degrees, it's already the angle there. So we're going to be using the cosine and sine formulas to find the x and y components. So 280 cosine 28 degrees. Always start with the magnitude, cosine, angle. So now magnitude, sine, angle. Using our calculator, 180 cosine 28, 247.7.2253, 2253. Now sine, just switch it to sine, 131.45, 131.4520. Now our component form of the vector would now be 247.2253, 131.4520. Now for our other vector, which is after dropping the supplies, the plane flies to Lake B. It flies to Lake B here, and at 190, with a distance of 190 kilometers and the direction of 30 degrees west of north from Lake A. Okay, here's where it gets important. As I said a while ago, the angle should always start from the east of the x-axis. So just east of the x-axis, or basically it should start from quadrant 1, okay? X-axis is quadrant 1. So now, since we know this quadrant here is 90 degrees, and this right here up to the resultant vector here is 30 degrees, what should be the total angle from here to here? We basically just add them up. So 90 degrees plus 30 degrees equals 120 degrees. I have to check, okay? 90 plus 30, 120. Okay, yeah, that's right. So now, we're gonna be using the same formula. So for the x component, it would be magnitude cosine 120 degrees, or the angle 190 sine 120 degrees for angle as well for the y-axis. So 190 cosine 120 negative 95, and if I'm not mistaken, the sine part would be 95 square root 3. Oh yeah, 95 square root 3. Yeah. So now our final component form of the resultant vector would be this. Now again, once we basically found the opposite and adjacent sides, and the opposite and adjacent sides, they're always, the parallel and anti-parallel vectors. That means these two vectors here, this x component vector and this x component vector here, I don't know if you see it here. No, we can just add them up because they are along the same, plane or the same axis. So now we just add them up. So for the x component, 247.2253 plus negative 95. For the y component, 131.4520, if I'm not mistaken, plus 95 square root 3. 95 square root 3 is, in decimal approximation, is 164.5448. So let's do this one first because it's already inputted here. So plus 131.4520 would be 295.9968 for the y component, and 247.2253 plus negative 95, 2253, 152.2253 for the x. So representing that into component form would be this. That is the component form of our resultant vector. So using the Pythagorean theorem, 152.2253 squared 295.9968 squared is equal to 5 squared 295.9968 squared would be 332.8462822, and for our unit would be kilometers. Yeah, that's our displacement. So this is our total displacement, or the magnitude of our displacement, 332.8462822. And I just wrote the entire thing, but of course you can represent it into 2 decimal places, 3 decimal places, as you like. But for the sake of the video, let's just represent it as is from the calculator. But make sure to always observe significant digits and stuff like that. Now we need the direction. Okay, so here's the part where we can use the butterfly method as stated from the first example. If you still don't know the butterfly method, please watch my previous video. Basically, it's on how to find the resultant vector. The first example of finding the resultant vector. So now with the butterfly method, we're gonna refer to what we're gonna refer on finding what quadrant exactly is our resultant vector located on. Now this component vector component here has a sign of positive. So referring to the butterfly method, we have positive here. This would be the angle that we're finding. That's this is the triangle of the vector. Okay, this is the vector itself. That's a triangle. That's it, really. So butterfly method is really useful. This part that we solve, this is what it looks like on a graph. That's the that's the sum of the vectors. That's it. So now we're gonna be using tangent -1, always b over a. So the 9968 all over 152.2253 equals shift tan 295. 62.78413731 degrees. Now that is the direction, or the angle, and the magnitude of our resultant. Now since it's already located in quadrant 1, the angle already started from quadrant 1, from the x-axis or along the horizontal. That's the angle. So this is the vector, that's the angle. So we don't really have to do anything with it anymore. And that is our final answer. Thank you for watching.